Hi everyone, this is a second lesson of unit conversions. These are a little bit more tricky type problems, and these types of problems I will call conversions for complex units. And what makes them complex is that they're just not your ordinary conversion of, say, a gram to a kilogram or something like that, but instead they're complex units in the sense that there's a numerator and denominator. And let me show you by an example. Let's say that we start off with 1.072 grams per milliliter, and I want to convert that unit of grams per milliliter to milligrams per deciliter. Okay, so in this problem it looks a little bit more tricky because what we need to do is we need to go from grams to milligrams, and that's going to be a one-step process. And then going from milliliters to deciliters is going to be a process too, but unless you know the direct conversion, and you may not, and that's okay, what they're both related to is this unit of liter. And so if we could figure out how to get from the milliliter to the liter, and then from the liter to the deciliter, we'll be able to answer this question. And the other thing I want you to notice is that the milliliter to liter to deciliter is in the denominator, and that's what's different. We haven't done those kind of problems. So let's see how you handle this. So the first thing that we need to know is we need to know the relationships first. Now, grams and milligrams, what's the larger of the two units there? We know that the larger of the two units is the gram. And so for every 1 gram, there's 1,000 milligrams. Let's head over to the milliliters to liters. And in that situation, what's the bigger of the two? Liter. And so for every 1 liter, you have 1,000 milliliters. And when we deal with the relationship of liter and deciliter, what's the larger of the two? Again, it's the liter. And deci is a tenth, so that means there's 10 deciliters in the liter. So this looks like it's going to take us 1, 2, and 3 steps to do it. So to do this problem, start off like we had before, 1.072 grams per milliliter, and in the end we're going to end up with the unit of milligrams per deciliter, and it's going to take us 3 steps to do it. So I'm putting my parentheses and I'm ready to go. So here it doesn't matter really what you start with. You could start with a numerator denominator. In this particular example, I'm going to choose to start with the numerator. And so in that case, I'm going to need to know the relationship between the gram and the milligram. Again, it's for every 1 gram, there's 1,000 milligrams. And so I want to get this unit to milligrams, so the unit that I want is going to end up being on the top. And there's 1,000 of those. And there's 1 gram on the bottom. And notice that the unit of gram cancels out, leaving me with the unit of milligrams, which is perfect because that's what I wanted. And then now some work on the denominator. Now notice the denominator is where we want it to end up. So in the end, we better end up with deciliters. And so if I want to cancel out the unit of milliliters, I'm going to use this relationship right here. And so in order to cancel out the milliliters, I'm going to have to use the relationship of 1 liter per milliliter. I have to flip it so that I have the milliliters on top. So for every 1,000 milliliters, I have 1 liter. Now in this case here, now the milliliters cancel and leaves me with the unit of liters, which is good. But again, I need to get to the unit of deciliters. So now I've done this first step. Now I need to do the second step. I have this relationship right here. To do that, I want this unit of liters to cancel. So I'm going to have to use the 1 liter up on top. 10 deciliters go on the bottom. Notice this cancels. It leaves me with the unit of deciliters on the bottom, which is good. It's exactly where I need it to be. So in this particular example, when I take 1.072 and I'm going to multiply that by 1,000, and then multiply this by 1,000, and then divide by 10, I end up with an answer of 1.07200 milligrams per deciliter. I could have written it in scientific notation, but I didn't need to. I think it's okay to leave it longhand if I need to.